Okay, good morning to everyone and good morning. This is your guy. This is your guy Donny Tutorials, right? Donny Tutorials is on Facebook and YouTube. Yeah, those two. And I hope everyone is having a good morning, right? Okay, today I want us to do functions, guys. Today I want us to do mathematics, paper one, functions. Functions. If you guys know functions, uh, by functions we're talking about graphs. So we're just gonna be dealing with graphs, right? And I'll try to make this video a bit longer. When I'm saying long, I mean like around 5 minutes, 7 minutes, somewhere around there. But then let's just get into it. Let's just get into it. Let's start with what you guys call linear functions. Some of you call it straight line function, right? This is a linear function or just a straight line function. How do we go around this function? What kind of a graph is a linear function, and how do we actually apply it? How does it work, and so forth, right? Yeah. Okay, check this one out. Linear functions, linear or straight line function. This is a function that comes in the form of this functions comes in the form of f of x equals to ax plus q. F of x equals to ax plus q, or rather maybe ax plus c, ax plus b. You just decide what that one. But I'm gonna use f of x equals to ax plus q. F of x equals to ax plus q. How does this thing actually apply? How does this thing actually apply? How do we apply this graph? So this is ax plus q, or it can come in the form of f of x equals to ax negative 2. These are just the same thing, but I'm gonna explain the difference between the two. So let me just start with it. This graph of linear functions is a graph like this one. See, let's check this one out. Let's check this slide here. This is our y-axis, and this one will be our x-axis. Let's check this line here. This line is in the this line cuts in the first and the third quadrant, right? First and the third quadrant. I hope that makes sense. Now let's check this one out about this graph. This is how this graph is, and if you check very well, there is something that we call the axis of symmetry, right? So I'm just gonna put these dotted lines here. Axis of symmetry. I'm just gonna put these dotted lines here. And this actually happens with this graph. This graph, the one you see here, making sense. First and third quadrant. Let's check something important. Let's check the value of a, guys. Let's check the value of a. The value of a. When a is positive, guys. When a, right? When a is positive. When a is positive, my graph will definitely cross in the first and the third quadrant, as you guys can see. As you guys can see, this is the value of a. This is what the value of a actually does to the graph. But if value of a is greater than 0, then I'm expecting my graph to be in the first and the third quadrant. The value of a. Now I want us to move to the value of Q. The value of Q, right? Q is the y-intercept. What do I mean when I say that Q is the y-intercept? I actually mean that Q when Q is positive, right? Hope that does make sense. When Q is positive, then my graph will touch the y-axis in the positive side, if I'm making sense. If you check the side, this is 1, 2, 3, 4 going forth, and this side is gonna will be -1, -2, -3, -4, right? So the value of Q actually determines where our graph will touch the y-axis, if I'm making sense. So if, let's say for example, my graph, let's say this graph touches here, which is y equals to 1, right? The y-intercept of this graph, as you can see, is 1. This graph touches 1, y equals to 1. So this actually means that my graph will definitely be, the value of Q here will be just 1, if I'm making sense, right? But if this graph touched this side, the negative side of our graph of the y-axis, if I'm making sense, if this graph touched this side, if this graph touched here, check this one out. Let me just say this is -3. This is -3, right? This graph touched the y-axis on the intercept y equals -3. I hope that makes sense. Then that means my graph will be a x -3. This Q will definitely stand for -3. I hope it does make sense as well. Yeah. Now, let me also explain something. Ne? What if my value of A is negative? What will happen if my value of A is negative? Let me just draw the graph here. If the value of A is negative, then I'm expecting my graph to be, or rather to cut in the second and the fourth quadrant, like this one, right? If f of x equals to -a, just say -ax plus q, or -q, will decide the value of a will determine, or rather the value of a will tell us that the graph should cut in the first. If the value of a is positive, if the value of a is positive, then my graph will definitely cut in the first and the third quadrant, right? And then if the value of a is negative, then my graph will cut in the second and fourth quadrant. I hope this one does make sense. But I want to move there. So let's check something also. Ne? Let's check something also. Ne? The value of a definitely tells us about the gradient of the graph. The gradient of the graph, right? The value of a also tells us about the gradient of the graph. But in this case, I want to explain it in the more simpler way. So in the simpler way, I'm saying that when the value of a is positive, then my graph should cut in the first and third quadrant. When a is negative, then my graph should cut in the second and fourth quadrant, right? Cool. And then the value of q, this is just the y-intercept. Why am I saying the y-intercept? Because when q is negative, when q is negative, then definitely my graph should cut then the y-axis in the negative side. I hope it does make sense. Then when value of q is positive, then my graph should cut the y-axis in the positive side. I hope that one does make sense. I want to move